This is our first video together, and it will be over section 5.5, solve by factoring. First thing we're going to do is review a little factoring. And my first problem, it should say 4x squared plus 8x plus 12. I apologize, I made a mistake. So the first thing that we're going to do is we factor out a common factor. Common factor is 4 in this case. So I take out a 4 and I'm left with x squared plus 2x minus 3. So I divided a 4 out of each of those terms. Now I look at my last term and I decide that I could have negative 3, 1 or 3, negative 1 as my factor pairs. And the pair that matches up to add up to a positive 2 is going to be 3 and negative 1. So now I'm simply going to rewrite, and I'm going to carry that 4, x plus 3 times x minus 1. Next one, the common factor here is going to be a 3. There's also a common factor of an n. Notice that your last term, when factored out completely, is always going to have no variable. It's going to be a constant. So I factor out an n, and I'm left with 3n minus 8. And that one's done too. Zero product property says that any number times 0 is 0. So if I have a times b equals 0, then a equals 0 or b equals 0. One of them has to equal 0. An example of this for what we're doing is if I had x plus 3 times x minus 7 equals 0, then x plus 3 equals 0, or x minus 7 equals 0. Now when I set something equal to 0, that means I've replaced the y. And we talked about when we graphed that when y equals 0, that is a solution. That's an x-intercept. So we can factor and find our solutions. So if we factor our first one, we look at the last term, it's a 7, and I could have 7 and 1, or I could have negative 7 and negative 1. The pair that's going to add up to get 8 is going to be positive 7 and positive 1. So I rewrite, and I say x plus 7, x plus 1, and I'm going to set that equal to 0, which means that x plus 7 can equal 0, or x plus 1 can equal 0. I solve each of these, and I get x equals negative 7, and x equals negative 1. If you were to put this in your calculator and look at the graph, you would find solutions at x equals negative 7 and x equals negative 1. Let's do our next example. Looking at our last term, negative 12, I can have 1 and negative 12, or negative 1 and 12. I could have 2 and negative 6, negative 2 and 6. Could have 3 and negative 4, or negative 3 and positive 4. The pair that's going to add up to be negative 1 is going to be 3 and negative 4. So I'm going to rewrite and say x plus 3 times x minus 4, and replace that y with 0. And now I have x plus 3 equal to 0, x minus 4 equal to 0. Solve each of those, I get x equals -3, x equals +4. And this c, I messed up again, and that should say 3x squared minus 18x plus 15. So notice on that one that there is a common factor. Our common factor is 3, so I'm going to take a 3 out. I'm left with x squared minus 6x plus 5. I divided the 3 out of each term. And now I look at my last term. It's a 5, and I could have 5 and 1, or -5 and -1. To add up to get -6, I'm going to use -5 and -1. So I keep my 3, and I rewrite. I do x minus 5, x minus 1. Set that all equal to 0. And what I'm going to do with my 3 here is this is all multiplication, so I can divide by 3. And 0 divided by any number is 0. So that little 3 just kind of disappears for us. And now I can say that x minus 5 equals 0, or x minus 1 equals 0. If I'm going too fast, you can pause the video. You can go back and listen to it again. And I get x equals 5 and x equals 1. Example D. Again, we're looking at our last term. But first, I have to get the last term over with the rest of the problem. So I'm going to have to subtract 18 from both sides. And I end up with x squared plus 7x minus 18 equals 0. And sometimes you will see it like that. It's not going to be all pretty all on one side, so you have to get it all together in order to factor. And now I'm looking at my last term, and I can get -18 with 1 and -18, -1, +18, 2, and -9, -2, and 9, and I'm just going to stop right there because I already see that I'm going to use -2 and +9. So I do my rewrite, x minus 2, x plus 9 is already equals to 0 for us. X minus 2 equals 0, x plus 9 equals 0. X equals 2. X equals -9. Try these next two on your own. Pause the video and try them. And then I'm going to solve them. And I'm just going to go through them without talking quickly. So pause now and try them. Okay, so in both of these problems, x equals 0 is a solution. So I have x equals 0, x equals 3/4, and for the second one, x equals 0, x equals 1/2. Factoring special cases factoring a difference of two squares, you might have done this in Algebra 1, but when I notice that I have two squares and it's subtraction, that's what difference means, subtraction, I can easily write that as a plus b times a minus b. I don't have to worry about what factors are going into it. I don't have to worry about which ones are adding. It's plain and simple. So what you do is you notice, oh, I have an x squared. That's obviously squared. 49 is a perfect square. So I'm going to rewrite it so I have x squared minus 49 is 7 squared. And now it looks just like my a squared minus b squared. A is x and b is 7. So I'm going to write x plus 7 times x minus 7. And I didn't have to do any extra thinking. If I set this equal to 0, I have x plus 7 equals 0, x minus 7 equals 0, and then I have x equals negative 7, x equals 7. And I did that, subtract 7 and add 7 in my head. Next one, a little bit more complicated. I have to worry about this 4. 4 is also a perfect square, but I have to write it with the x inside parentheses. So rewrite both of them. And then the 2x is the a and the 5 is the b. So you're going to write 2x minus 5, 2x plus 5. It doesn't really matter whether you do the plus parentheses or the minus parentheses first, because it's multiplication, and 2 times 3 is the same as 3 times 2. And now I set both of these equal to 0, so I have 2x minus 5 equals 0, and 2x plus 5 equals 0. 5, 2x equals 5, divide by 2. X equals 5 divided by 2. Subtract 5. 2x equals negative 5, divide by 2. X equals negative 5 over 2. And last one, again, the 9 is a perfect square. So I'm going to write that in parentheses with the x. This is when it's good to know your perfect squares, be able to recognize them, because it's going to save you a lot of hassle when you're factoring. 3x minus 8, 3x plus 8, set that equal to 0, 3x minus 8 equals 0, 3x plus 8 equals 0, 3x equals 8, divide by 3, x equals 8 thirds, subtract 8, 3x equals negative 8, divide by 3, x equals negative 8 over 3. And what I'd like you to try is go back and graph some of the equations. You don't have to do all of them, but graph some of the equations in your calculator just to double check and prove to yourself that they are in fact the correct solutions.